So guys, we'll be looking at multiple linear regression in matrix form, and in this example we'll be looking at multiple linear regression of two independent variables, and that's why we have this model: y subscript I equals to beta naught beta 1 x1 beta 2 x2 plus noise, which is the error term. So in this model now we have two independent variables, which is x1 and x2, and we have one dependent variable, which is y. Now in representing this model in matrix form, that leads us to what we have here as y equals to x beta plus e, whereby beta, this beta here contain, we have beta naught, beta 1, beta 2. So which means if you have more than two coefficients here or three coefficients here, this is going to be the coefficient vector. So now our y now is y1 y2 up to the number of y that we are dealing with. Then in this case we have an x beta, which x is the independent variable, and like we said in this example we'll be looking at two independent variables, and that's why we have x1 and x2. So this is the column for the x1 and this is the column for the x2. Now why do we have one here? The coefficient of this beta naught here, which is our constant, and that is why we have 1 1 1 1 1 here. Then this is beta, which is the beta naught, beta 1 and beta 2, and we have our error term, which is error term 1, error term 2, that it's white noise. So we assume that all assumption of regression is fulfilled. So we'll be using this example for academic purpose. It's just to show us how to use matrix form to get the coefficient of multiple linear regression. So let's go, guys. All right, so this is the example here, and this example says find the coefficient of regression, find the coefficient of regression in matrix form from the data below. And if you look at the data, we have y column for the dependent variable y, we have column, this is the independent variable x1 row, this is the independent variable x2 row. So in this table now we have one dependent variable is our y, and we have two independent variables, and the two independent variables are x1 and y1. So just like we did in the matrix notation, we are going to form this, which says y equals to all the value in the row of y, say 9, 10, 13, 14, 16. That is the column for y. Now that of x, say x equals to, say 1, 2, 3, 4, 5, because we have a 5 number of observation. Then for the x1, we say this is for the x1. Now we say we have a 1, 3, 4, 6, 7, and for the x2 here we have this value there, which is a 10, 14, 15, 18, 20. So that is that. Our y, this is the vector, y vector, and we have this matrix notation for x, which is 1 1 1 1 1 3 4 5 6 7. This is for x1. We can see x1 and x2. This column is for x2. Now how do we get the coefficient of the regression? Now we said beta equals to x prime x inverse multiplied by x prime y. By the time we will multiply all this together, that is going to give us the coefficient of the regression, which is in beta naught, beta 1 and under beta 2. And what do we have in x prime? X prime is a transpose of x, and if you look at this is our x. So by the time we transpose this x, that is what we are talking about. Now let's look at the transpose of x. We said x transpose, we are dealing with this now. X transpose will be, that is, all the row become column, the column become the row. Now this is the first row, all this, this is the first column, all the first column become the first row. So we have 1 1 1 1, and the second column become the second row. 1 3 4 6 7. The third column become the last row here. 10 14 15 18, then we have 20. So this is our x prime. So now the first thing we are going to do here is to multiply this x prime by this x. We'll multiply x prime by x. So how do we do that? It says, okay, it says x prime x will be equals to this matrix here: 1 2 3 4 5, 1 3 4 6 7 10 14 15 18 and 20. Multiply by this matrix here, which is our x. Since 1 1 1 1 1 1 3 4 6 7 10 14 15 18 20 18 20. So what are we doing here? We're using this matrix to multiply this matrix, that is x prime multiplied by x. And how do we do this? We say this is equals to, now this is what we are going to do here. Now what we are doing here is the first row multiplied by each number in first row multiplied by corresponding number in the column. 1 times 1, 1 plus 1 times 1 plus 1 times 1 plus 1 times 1 plus 1 times 1. That is what we are doing here, and that will give us 1 plus 1 plus 1 plus 1 plus 1. Let me put it in bracket. So well, 1 plus 1 plus 1. All right. So secondly, we're going to use this same first row to multiply the second column. 1 times 1 plus 1 times 3 plus 1 times 4 plus 1 times 6 plus 1 times 7. That is what we are doing here, and that will give us 1 plus 3 plus 4 plus 6 plus 7. Now we're still using the same row to multiply the last column here. We say 1 plus 1 plus 1, 1 times 10, 1 times 14, all that. So we are going to have 10 plus 14 plus 15 plus 18 plus 20, because we are using 1 1 1 to multiply through. Now the second row here, we're going to use this second row to get all the value in this second row. That is, this row multiplied by this column. 1 times 1, 3 times 1, 4 times 1, 6 times 1, 7 times 1, and that will give us 1 plus 3 plus 4 plus 6 plus 7. Now we are using the same row to multiply this column, and how do we get here? 1 times 1, 1 plus 3 times 3, 9 plus 4 times 4, 16 plus this times this, 36 plus 7 times 7, and that is 49. Then we are using this same row to multiply the last column here. 1 times 10, 10 plus 3 times 14, 42, plus 4 times 15, so 60, plus 6 times 18, that is 108, plus 7 times 20, 140. So we are done with that. Now we're going to use this last row to multiply the first column in order to get the last row here. So 10 times 1 plus 14 times 1 plus 15 times 1 plus 18 times 1 plus 20 times 1, and that will give us, says 10 plus 14, 15 times 1 plus 15 plus 18 plus 20. Now we are using this last row to multiply the second column here. That is 10 times 1, that will give us 10, 14 times 3, 42, plus 15 times 4, 60, plus 18 times 6, that is 105, plus 20 times 7, that's 140. And here we are trying to get the last box here. We're using these to multiply the last row here. It's like we are squaring each value here. 10 times 10 plus 14 times 14 plus 15 times 15. And what is that going to give us? It is going to give us 100 plus 100 plus 14 times 14, 196, plus 15 times 15, 225, plus 18 times 18, 324, plus 20 times 20, and that will give us 400. 20 times 20. So this is our matrix for this. So by the time we add all this together, say 1 plus 1 plus 1 plus 1 plus 1, and that will give us 5. 1 plus 3 plus 4 plus 6 plus 7, that will give us 21. 10 plus 14 plus 15 plus 18 plus 20, that will give us 77. 1 plus 3, this bracket is same as this bracket here, so this will be 21. Now 1 plus 9 plus 16 plus 36 plus 49, that will give us 111. Now 10 plus 42 plus 60 plus 108 plus 140, that will give us 360. If you use your calculator, very well. Now the last column, 10 plus 14 plus 15 plus 18 plus 20, which is something as the bracket here, this will give us 77. 10 plus 42 plus 60, which is something as this box here, and that will give us 360. Now 100 plus 196 plus 225 plus 324 plus 400, with the help of calculator, we're going to have 1245. 1245. So this is our x prime x. That is our x prime x. Alright, now, but in this model here, we are not just looking at x prime x, we are looking at x prime x inverse, then multiply by x prime y. So we can decide to look for our x prime x now, or later we look for x prime y. So what do we do now? So it says, so now let's look for, we've gotten our x prime x, now we need x prime x inverse. Now before we look for x prime x inverse, let's look for x prime y. Now x prime y, so x prime y, and this is going to be our x prime, which we need this value 1 1 1 1 1 1 3 4 6, 7, 10, 14, 15, 18, 20, then multiply by y, and our y is this matrix here. 9, 10, 13, 14, and 16. So that is our y. We are multiplying this matrix by this matrix, and you can see this is 3 by 5 matrix. It's saying 3 by 5 matrix multiply by, this is 5 by 1 matrix, 5 by 1 matrix. This 5 cancel this 5, then we're going to get 3 by 1 matrix. So the answer we're expecting here is to be 3 by 1 matrix. Now let's do it here. So 3 by 1 matrix. Alright, now let's go, guys. So this column multiply this row multiply by this column. 1 times 9, 9 plus 1 times 10, 10 plus 1 times 13, 13 plus 14 plus 16. Alright, now we're using the second row to multiply this column. So 1 times 9, so 9 plus 3 times 10, 30 plus 4 times 13, 52 plus 6 times 14, 84 plus 7 times 16, and that will give us 112. Now the last row multiplied by this column, so 10 times 9, that is 90 plus 40 times 10, that will give us 140 plus 15 times 13, that will be 195 plus 18 times 14, that is 252 plus 20 times 16, and that is a 320. Now this here, therefore our x prime y will be equals to, if you add all this together, 9 plus 10 plus 13 plus 14 plus 16 using calculator, we're going to have a 62. 9 plus 30 plus 52 plus 84 plus 112, that will be 287. 9 plus 140 plus 195 plus 252 plus 320, that will be 997. So this is our x prime y. Alright, now let's now look for our x prime x. Now before we move any further, let me write our x prime x here before we look for the inverse. Right from here, these are x prime x. So x prime x, this is the value here. So x prime x equals to this matrix 5. Right, let me just put everything here. So it's equals to 5, 21, 521, 77, 21, 111, 360, 77, 360, 1, 2, 4, 5. So that is our x prime x that we got on a time. Alright, so what are we doing now? We are going to look for the transpose of these x, the transpose. And how do we get the transpose? We say this is equals to x prime x inverse equals to 1 over determinant of x prime x multiplied by the adjunct of x prime x equals to the adjunct of x prime x. All right, so here now we need to look for the determinant of x prime x. Then after getting the determinant of x prime x, we're going to look for the adjoint of x prime x. Now the adjoint, how do we get the adjoint? So the adjoint of x prime x equals to cofactor of x prime x transpose. So before we were able to get our adjoint of x prime x, we first of all need to get the cofactor of x prime x, then transpose it. That is when we are going to get our adjoint of x prime x. But let's begin by finding the coefficient, by finding the determinant of x prime x. So we need to get the determinant of x prime x. All right, let's go there, guys. So determinant x prime x equals to 5, 21, 77. These are x prime x. 21, 111, 360, 77, 360, 124, 5. Now we're going to look for the determinant. Now you should know that there are so many ways of getting determinant, but in this case now we're just going to look for the determinant and move on. So here we have a plus, minus, plus. So what do we have here? Well, we'll pick 5. Say 5 x prime x, say 5. When you pick 5 now, all this column, all this row and this column will be neglected. This row and this column will be neglected. By the time you ignore this row and this column, it will remain just this side. 111, 360, 360, 124, 5. So that's what we have there. So minus 21. What is the cofactor here? By the time you cancel this column and you cancel this row, cancel this column, cancel this row, we have 21, 360, 77, 1245. Then plus 77, plus 77. So by the time you cancel this row, by the time you cancel this column and you cancel this row, so we will be left with just 21. You can see 21, 11, then 77, and 360. So 360. All right. So now, what next are we going to do now? What we are going to do now is going to be, so this is equals to 5 into bracket. Now see what I'm doing. So this multiplied by this minus this multiplied by this. 111 multiplied by 1245 minus 360 multiplied by, it's just like cross multiplying, then you subtract the result of the cross multiplication. And here by the same 111 times 1245 minus 360 times 360, this will give you 8595 minus 21. We're going to do same thing here, and this is going to give us minus 1575 plus 77. 21 multiplied by 360 minus 77 multiplied by 111, and that will give us minus 987. All right, so open this bracket. We're going to have a 42975 plus 33075 minus, if you multiply this, so we have 75999, and adding all this together, our determinant of x prime x will be equals to 51. So our determinant, which is x prime x, will be equals to 51. All right, this is not the end. Then we need to find this cofactor of x prime x. Cofactor of x prime x. That is all we are going to find now. And how do we do that? Well, exactly the way we form the determinant of this x prime x. That is how we are going to get the cofactor of x prime x. All right, let's start with this, guys. We said, okay, cofactor of x prime x. That is what we are getting. We are going to get now. And how do we do that? Now let's see what we are going to do. We said cofactor of this 5 here. That means this row, this column is gone. We are picking this. So this is equals to 111 360 360 1245. Let me put this matrix notation here. Now for 21 we are going to have this column, this row is gone, so it remains 21. That is for 21. This, strike this out, strike this out. So we're having 21 360. So 21 360 77 1245. And for the third one, 77. How do we get that of 77? We said, all right, this column and this row is gone, so we are left with 21 111. So 21 111, then 77 360, because this column and this row is gone. It's 77 360. Okay, so for this second row, by the time you pick 21, this row is gone, this column is gone. We are left with 21 77 21 77 360 1245. That is for this 21. This row is gone, this column is gone, so we have 21 77 360 1245. Now picking 111 here, 111. By the time you pick for that of 111, this column, this row is gone, remain 577 77 1245. 577 77 1245. And the cofactor for 360, this row, this column, so remain 521 77 360. So 521 77 360. Now for the last row here, the cofactor of 77, this row, this column is gone, remain 21 77 111 360. So 21 77 111 360. So for this, the cofactor, close this, 577 21 360. So 577 21 360. And for the last, the cofactor for this 1245, close this, 52 remain 521 21 11 111 521 21 111. So this is the cofactor of this. And what are we doing here? We are going to look for the determinant. We look for the determinant of this cofactor here. And how do we do that? So before we do that, let's assign the sign. So the sign here will be positive, negative, positive, negative, positive, negative, positive, negative, positive. We are not adding this together. What we are doing here now is to look for the determinant of each cofactor here. So we're going to do this way. Since this equals to, all right. So 111 times 1245 minus 360 times 360. If you subtract it very well, this we're going to get 8595. And do not forget that the sign we are having here already is positive. So we have positive. The cofactor already have minus. Now 21 multiplied by 1245 minus 360 times 77, and that will give us minus 1575. So for the third, we have plus 21 times 360 minus 77 times 111. If you use your calculator, you're going to have minus 987. You have minus 987. Alright, if you do it for the rest, just like we do for the first here, we're going to have a minus, because we have minus here. So the determinant here is going to be minus 1575. Here we're going to have, plus. The determinant of this dot is going to be 296. We have minus here, minus. The determinant of this dot is going to be 183. So for the last part here, we have a plus here. Determinant of this will give us minus 987. So here we have minus into bracket. Determinant of this box will give us 183. Plus, we have plus here. The determinant of here is going to give us 114. So by the time we open all these, this is going to give us, this is going to give us 85, 95, 1575, 987. Minus times minus will definitely give us a plus. So we have and you should not forget that here we have minus times plus here, which is a minus. So here we're going to have 1575 minus times minus plus. Here we're going to have 296, and here we're going to have minus 183. So the last part here we have minus 987. Here we have minus 183, and the other part here we have 114. So this is the cofactor of x prime x. All right, now in this case, now we need the other one, which is the transpose of this cofactor of x prime x. So we have a cofactor x prime x transpose is going to be, the row here becomes the column, the row becomes the column, and in this case cofactor x prime x transpose will give us the adjunct of x prime x. So in this case now we're going to have this, now says this is equals to, the row become the column, says 8595 1575 minus 987. Row become column, the row here become the column here, 1575 296, you have minus 183, and in this point the row here becomes the column here, minus 987 minus 183, then we have 114. So now the transpose of cofactor of x prime x is the same thing, will give us the adjunct of x prime x. So now we've gotten the adjunct of x prime x, which is this matrix, and the determinant of x prime x is already 51. So multiplying these two together is going to give us the x prime x inverse. It's going to give us x prime x inverse. So guys, are you there? Let's move on. So x prime x inverse. Now, so from here now, we said our x prime x inverse, which is equals to 1 over determinant of x prime x. Determinant of x prime x here is 51. So here we're going to have a 51 multiplied by this adjunct of x prime x, and right from here the adjunct of x prime x is 8595 1575. So here we're going to have 8595 1575 minus 987 1575 269 minus 183 minus 987 minus 183 114. So this is the inverse of x prime x. Now from our formula, the main formula here, the one we did the other time, which is we says okay, we need for us to get our beta, and our beta here is supposed to be x prime x, and I'll show about that. All right, okay, from here now we said x prime x. So now for us to get our these coefficients of beta, we're going to have this same beta equals to x prime x, and our x prime x is already this value, which is 1 over 51 into bracket 8595 1575 minus 987 1575 269 minus 183 minus 987 minus 183 114, then multiply by x prime y. And where is our x prime y? This is our x prime y here. Our x prime y is 62,287, then 997. So we say multiply by x prime y, and our x prime y is given as this, just the way I showed you just now. So 62,287 997 equals to our beta naught, beta 1, beta 2. By the time we multiply this together, we are going to get the corresponding value for the coefficient of this multiple linear regression. Alright, so now let's multiply this by this and see what we are going to get at the end of the day. Alright, since we have so this is going to be 1 over 51. And what is our matrix here? Our matrix here is a 3 by 3 multiplied by 3 by 1. If you multiply 3 by 3 matrix together with 3 by 1 matrix, what are we going to get? We're going to have a 3 by 1 matrix. Our final result is going to be what? 3 by 1 matrix. So that is what we are going to do now. All right, so bracket open, right? 8595 multiplied by 62 with the help of calculator. 8595 multiplied by 62, that will give us 532890 plus 1575 multiplied by 287, that will be 452025 minus 987 multiplied by 997. That will give us minus 984039. The second part here is said 1575 multiplied by 62, and that will give us 97650. 269 multiplied by 287, we have plus 84952 minus 183 multiplied by 997, that will be minus 182451. Now minus 987 multiplied by 62, that will give us minus 61194 minus 183 times 287, that will be minus 52521. 114 multiplied by 997, and that will give us plus 113658. By the time we simplify this, we're going to get beta naught, beta 1, beta 2, and let's see, this is equals to 1 over 51. Our beta equals to 1 over 51 into this matrix here. So if you add this together, 532,890 plus 452025 minus 984039, that will give us 876. Adding all this together will give us 151. Adding all this together will give us minus 57. Minus 57 equals to, so we can either leave our answer this way, or better still, we divide each value here by 51. You can see this matrix is by 51, that is 876 divided by 51, 151 divided by 51, minus 57 divided by 51. So approximately this is going to be 876. So let's say 876 over 51, 151 divided by 51 minus 57 divided by 51, and this approximately will give us 17.1765, 2.9608 minus 1.1176, and this is our beta naught, beta 1, beta 2. So which means our beta naught is 17.1765, our beta 1 is 2.9608, our beta 2 equals to minus 1176. So let me just write this as beta naught equals to 17.1765, beta 1 equals to 2.9608, and beta 2 equals to minus 1.1176. Now our regression, multiple linear regression model, which is y equals to beta naught plus beta 1 x1 plus beta 2 x2, now will become y equals to, and our beta naught is 17.1765 plus our beta 1, which is 2.9608, and don't forget that our beta 2 is minus, so this minus is affecting this. Then before that we have x1, the minus 1.1176, and we have an x2. This is our multiple linear regression model for the data given to us to do it. And let me show you the procedure now. Started from here, right here, then we do this as our final answer. And before the final answer, we use this in order to get the inverse of our exponent x. So that is how to solve the multiple linear regression in matrix form.